In this lesson, we're looking at measuring angles in a different way. So far, for most of your mathematical career, you have measured angles in degrees. In this lesson, we're going to talk about measuring angles in radians. And before we do that, we want to kind of expand the way that we talk about angles. In this context, we consider an angle to be formed by the rotation of a ray. So here's kind of what I'm looking at. If I think about this side of the angle being my initial side, that's my starting point, when its terminal side coincides with it, notice that it's really stinking close to zero. Okay, but as I rotate that ray, now I'm forming an angle, and the more and more I rotate it, the bigger and bigger my angle gets. So I wanted to kind of show you interactively what I mean by rotating the side of the angle in order to find an angle. Okay, so once again, the horizontal side that I showed you here, this is what I call my initial side, and this is the terminal side of the angle. And an angle in standard position has its initial side on the positive x-axis. So actually, I shouldn't have done that. In my GeoGebra, if I were to rotate it clockwise from the initial position, you would notice that GeoGebra measures the angle as positive 305, and that's because it's thinking of it in a geometry context, whereas we're thinking about it in a advanced topics / pre-calculus context. If I rotate counterclockwise, that's a positive angle. If I rotate clockwise, even though the screen says something different, in this course, when we are looking at an angle rotated like this, we're thinking about it as a negative angle. Okay, so now we're kind of exploring the prospect of negative angles, which certainly you never ever considered in your geometry class. So notice the definition for a radian. I can't say I'm terribly fond with the way that the book describes a radian. So here's how I want to describe a radian. A radian is basically, one radian is how much of an angle I need on this circle in order to take this radius and wrap it around the circle. So here's something I kind of want you to notice about radians. So I've changed my GeoGebra so that it's measuring angles in radians. Okay, so here is approximately 1 radian, which means that this length going around the circumference of the circle is equivalent to 1 radius of the circle. Okay, so how many radians, how many radius is, how many radii does it take to go around the entire circle? So there's 1, here's 2, there's, oh, that's an interesting number right there. And so if it took 3.14 to get halfway around, I would hope that you'd notice I can't see it because it's hiding. Oh, there it is. All the way around, that's 6.28 approximately, which I'm really, really hoping you would notice. Whoops. Is really darn close to 2 pi. So that's why you'll notice that the 360 degrees that it takes to go all the way around a circle, that's equivalent to 2 pi. So if I take that ratio of 2 pi to 360 and I reduce it, you see the 2 different ways that we can use that ratio to convert between radians and degrees. So let's get some practice doing that. Now, in order to convert 210 degrees into radians, I'm going to use this formula and take 210 and multiply it by pi over 180. And my answer will be in radians because I won't have radians canceling out. That 210 over 180, please, please, please don't divide that out and get funky decimal. Notice how radians are expressed in fractions. Get used to those fractions. They're not going away. By now, hopefully you have a scientific calculator that can help you reduce fractions if reducing fractions is something that you struggle with. So in your scientific calculator, when you take 210 over 180 as opposed to divided by 180, now your calculator spits back possibly 1 1/6. We don't express radians as mixed fractions. Sometimes it's helpful to think of it that way, and we'll get to that later. But when we're giving the measure, we want it as an improper fraction. So you have a function in your calculator that will change a mixed fraction to an improper fraction. And when you do, you get 7 pi over 6. And you'll notice in those underlined problems C and D that you don't see the word radians. It's because it's kind of redundant. Because the ratio of a radian is 1 to 1 between the radian and the radius, it's the measure of the angle is 7 pi over 6, and that's it. So in part B, similar idea. We're taking that negative 60 and multiplying it by pi over 180. And you reduce the fraction and you get negative pi over 3. In parts C and D, we're going in the opposite direction. So we do 4 pi over 3 times, this time 180 over pi. And you'll start to notice that the pi's usually, very conveniently, cancel each other out. And so in your calculator, you're doing 4 times 180 divided by 3, and that's 240 degrees. Last one, negative pi over 6 times 180 over pi. Again, conveniently, the pi's cancel out, and 180 divided by 6 is 30, so the measure of this angle is negative 30 degrees. In this GeoGebra, it doesn't show, for example, if I start here and I go all the way around once and then I keep going, the GeoGebra shows it as starting over. Here in trigonometry, when we're talking about trig in a pre-cal or advanced topics context, we talk about this going over 2 pi and becoming more than 360 or more than 3 pi. And so, for example, this 0.6 would have the same terminal side as this 2 pi plus 0.6, if you catch what I just did. Because I went all the way around, that was 2 pi, and then plus another 0.6. So when we talk about coterminal angles, whether we're talking about them in terms of degrees or radians, we're talking about an angle that has the same terminal side. And as I mentioned, going all the way around a circle in degrees is 360, and going all the way around a circle in radians is 2 pi. So basically, we're just taking the angle and adding that 360 or that 2 pi, multiples of that, to the original angle. Okay, so identify all angles that are coterminal with the given angles. If I take negative 30, take negative 30 and I add 360 over and over and over again, so that's where the n comes in, all of those angles will be coterminal with negative 30. And then it says to find and draw one positive and one negative coterminal angle. So negative 30 is about here. So if I were to go positive coterminal, that would be 180 plus 90 plus 60. And that is 330. So a positive one is 330, and a negative one would just be negative 30 minus 360. So that would be negative 390. So this is a positive one. And a negative coterminal angle would look like this. And the arrows are valuable in kind of demonstrating the direction in which we're going. All right, for the other one, all angles that are coterminal with 3 pi over 4 is just 3 pi over 4 plus 2 pi n. So if I'm adding a whole circle over and over again, all of those angles will be coterminal. If I draw this angle, well, we know that 1 pi is 180 degrees, and so half of that is 90 degrees, which means 3/4 pi is about here. And hopefully you're starting to kind of make enough connections that you would realize that this angle here is 45. And if you're not there yet, it's okay. Take time to get used to. You'll be all right. So that is my original angle. An angle coterminal with it, a positive angle coterminal with it, would just be 3 pi over 4 plus 2 pi. So and 2 pi is equivalent to 8 pi over 4, so that I can get a common denominator. And when I add those two fractions together, I get 11 pi over 4. So a positive coterminal angle would be 11 pi over 4. And a negative coterminal angle would be starting from here, going this pi, and then this additional pi over 4. So negative would be negative, okay, let's go through that one more time. That was pi plus another pi over 4. Well, pi is equivalent to 4 pi over 4. And when I simplify this, I have negative 5 pi over 4. And that is a negative coterminal angle. Finally, radians give us a really nice, easy formula that we can use to find arc length. If you recall, arc length is the length around a circle or a portion of a circle for a certain angle measure. And if you remember it from geometry, it was not a pretty formula. In this course, when we're measuring angles in radians, it becomes a much nicer, neater formula. That the arc length, S, is just the radius times the angle measure in radians. Okay, so in 4a, I am given the angle in radians. That's really convenient. So I can just plug this into the formula. S equals 2 times 2 pi over 3. And if it helps to put this 2 over 1, then do that. You multiply straight across the top and straight across the bottom. You get 4 pi over 3 meters. In part B, before you can use that nice neat formula, you've got to convert the 135 into radians. So remember how we do that. 135 over 1 if it helps, times pi over 180. Once again, don't just divide that 135 by 180. Take the 135 over 180 and reduce it. And it reduces to 3/4. Okay, so now my angle measure is 3 pi over 4. I know my radius. I'm ready to just plug into the formula. S equals 0.5. You know what? Let's make our life easier. That's 1/2. Times 3 pi over 4. Straight across the top and straight across the bottom. That's 3 pi over 8 feet.